Hello, I'm Durrell Hillis, Senior Vice President and General Manager of Motorola's Satellite Communication Division. On behalf of the more than 1,000 people who work here, I'd like to welcome you to our facility here in Chandler, Arizona. In 1987, 3 Motorola engineers came up with an idea. They had a vision to create a communication system that would operate not by wires or cables, but by satellites orbiting the Earth. Today, that idea has generated a revolutionary global communication system we call Iridium. The Iridium system is a sophisticated digital satellite communication network which will provide worldwide fax, data, voice, and paging communications from virtually any location on Earth. Iridium has brought together an unprecedented international consortium of partners from Europe, Russia, China, the Middle East, and the Americas. As prime contractor, Motorola Satellite Communications is the heartbeat of this massive global endeavor. From our headquarters here in Arizona, we are integrating and we are assembling the sophisticated low Earth orbiting satellites. And our experience in integrating systems and in creating state-of-the-art software will allow us to chart and control these technological wonders worldwide. What you're about to see is an inside look at key areas here at SATCOM that are vital to the success of the Iridium program.
The first thing you see when entering Motorola Satellite Communications Division's 500,000 square foot facility is a full-scale model of an Iridium satellite.
What makes Iridium unique is its constellation of low Earth orbiting satellites. To put the satellites in orbit, we use a combination of 3 international launch partners. From Russia, we will be using a launch base in the Kazakhstan province. In China, we will be launching from a launch facility just west of Beijing. Finally, for the McDonnell Douglas rocket, we will be using Vandenberg Air Force Base, California, to put our satellites into orbit. We feel we have assembled the best team of international partners to maximize the program's success.
Weighing 1,500 pounds each and traveling nearly 17,000 miles per hour, this constellation of 66 low Earth orbiting, or LEO satellites, will allow handheld telephones to be much smaller than those needed by other space-based systems, small enough to fit in the palm of a hand. Motorola Satellite Communications Division will provide comprehensive integration and testing for the entire Iridium system. Maintenance and control of all Iridium satellites will be accomplished by 3 control facilities, including a master control facility in Northern Virginia, a backup control facility in Rome, Italy, and the SATCOM control facility in Chandler, Arizona. In fact, the first 40 satellites launched during the initial buildup of the constellation will be managed and controlled right here in Chandler. Managing a large constellation of satellites flying in a prescribed formation requires far more sophisticated methods than those used in the past.
One of the unique features of the Iridium system is its use of crosslinks. These are the links between the satellites up in space. Each satellite has 4 links, one forward, one behind it, one to the left, and one to the right. These different links form a network up in the sky that allows us to route telephone calls around the entire globe.
Once calls are moved through the satellite network, the next step is to bring them down to a terrestrial gateway station, where they're connected to the existing landline system. Each gateway must be continuously connected to the satellite constellation for the Iridium system to operate successfully. Four remote antenna sites will provide telemetry, tracking, and control services during the deployment of the Iridium system. These sites include Waimea, Hawaii, Yellowknife and Iqaluit, Canada, and a transportable tracking station located in Adar, Iceland. When a satellite enters one of these areas, that particular ground site will be able to communicate directly with the satellite and relay important information on the status of that satellite back to the control center. The SATCOM antenna compound is located on a 3-acre site just east of the main SATCOM facility. This compound consists of 3 C-band geostationary satellite antennas, which will provide communication links to the tracking stations. A TVRO antenna, which will monitor international news and weather for launch and system operation support. And 2 K-band Earth terminals housed in radomes, which are used for integration and test purposes.
The radome you see behind me is a covering that's over our tracking antennas that follow the satellites when they come up over the horizon. We need to cover those antennas so that wind will not cause vibration to get mixed in with the signals that we're trying to receive from the satellite.
The Gateway Lab Control Room, with its large operator screens, is part of the SATCOM Integration and Test Laboratory. Sitting at computer consoles, gateway operators will be provided instantaneously with information on gateway operation and maintenance, as well as the status of all gateway equipment. The lab also includes a terminal room, where the systems integration and test group, along with the gateway test group, write various scenarios, which will test all Iridium system equipment. An adjacent room houses the gateway communications equipment, which is similar to the equipment gateway operators will install in their own gateway central facility. This equipment includes mandatory battery backups for all uninterruptible power systems, as well as the Motorola-supplied Earth Terminal Controller, which compresses voice, fax, data, and paging signals, allowing thousands of subscribers to communicate simultaneously. The Earth Terminal Controller also maintains continuous connectivity between the Gateway Switching Center and the Iridium constellation.
The SATCOM lab will not only test all of the hardware and software of the Iridium system, but we're also evaluating a number of systems that the gateway operator must install in each of his gateway central facilities. For instance, we've built this lab control room to look exactly like a control room that the gateway operator may use at his gateway central facility.
By closely coordinating design and manufacturing, Motorola and its partners will reduce the cycle time required to build each Iridium satellite from 3 years to a mere 3 weeks. Iridium spacecraft and subsystems will be assembled as modules, moving the structures from station to station through a 12,000 square foot factory that can handle 3 satellites simultaneously. The overall process is designed to simplify assembly checkout and reduce the need for testing.
We're simply testing at the next higher level. In a classical satellite facility, you end up retesting everything, and 60% of the total time for manufacture is involved in testing. We've reduced all of that cycle time and in fact eliminated most of it.
Additional reductions of cycle time in the manufacturing area are being generated through the use of the Pathfinder, a prototype full-scale model of an Iridium satellite. The Pathfinder provides operators, engineers, and technicians detailed training in assembly of modules by defining the manufacturing processes before entering the final production phase. From the manufacture, telemetry, tracking, and control of the Iridium satellite constellation to the integration and testing of the entire Iridium system, Motorola's Satellite Communications Division is committed to bringing the power of information to anyone, anywhere, at any time. Best-in-class professionals with the highest levels of expertise will maintain Motorola Satellite Communications' leading technological position well into the 21st century.